Hello and welcome back to Chapter 3, Section 1, Matter and Substances. Today we're going to look at the Part 2 video. Ultimately, we're going to be looking at why atoms form bonds and what are some important interactions between substances and living things. So if you recall from yesterday, we were talking about the atom itself. And if you remember, the protons and the neutrons were located in the center, and then around, and I'll draw some little dots in here to represent neutrons. But then around the outside of that, we had all these electrons, okay? And the electrons form a cloud because they're constantly moving. And in that cloud of electrons, sometimes we can have multiple levels, okay? And it's going to depend on the state of that atom. The electrons that are in the outermost level, or the shell that it's sometimes called, are what we call valence electrons, okay? And the valence electrons are actually what are responsible for how things bond, okay? And the ultimate goal when an atom is trying to bond usually is to get 8 valence electrons, okay? So they're going to try to combine with other atoms or elements, okay, to obtain these 8 valence electrons. So they could do that by sharing their electrons, which we'll talk about here in a minute when we talk about covalent bonds, or they might give and take to get 8 valence electrons. And when we give and take, we get what we call an ionic bond. When atoms actually combine, we get what we call a chemical bond that's actually going to hold the atoms together. And again, when atoms combine, they're trying to get 8 valence electrons, or 8 electrons in their outermost energy level. And they do this so that they are stable, because when an atom has 8 valence electrons, it's a stable atom. When atoms from different elements combine, we get what we call a compound. And a compound is nothing more than a substance that's made up of bonded atoms or of 2 or more elements. Okay, so something like NaCl, which would be like your table salt, this is considered a compound, okay, because I have sodium atoms and I have chlorine atoms that are combining chemically to create a new compound. And when I have salt or NaCl, the property of salt itself is different than the individual atoms of either sodium or chlorine. So as I mentioned earlier, there's a couple different ways that atoms are going to bond in order to get 8 valence electrons, okay? One way is what we call covalent bonding, okay? And this is something that you guys are going to need to know. Covalent bonding occurs when the valence electrons are shared, okay? So covalent bonding happens when electrons are shared in that outermost energy level. When you get a covalent bond, you actually create what we call a molecule. This is a group of atoms that are held together by covalent bonds. And an example of this would be a water molecule, okay? So this happens because an oxygen atom is going to share its valence electrons with 2 hydrogen atoms so that they each have what we call a full octet, or they have the most valence electrons that they need in their outermost energy levels. Now in class, I will play this video for you, so we'll skip this for now. The next type of bonding we're going to look at is what we call ionic bonding. And ionic bonding occurs or becomes like a stable bond when electrons are either lost or gained, okay, resulting in a positive or negative charge. And a sodium, okay, or salt, so again, I'm going to have NaCl. Sodium has 1 valence electron in its outermost energy level. Likewise, we have chlorine, which has 7. Okay, so what's going to happen is the 1 sodium atom is going to come over here to fill the chlorine, and then sodium then, when sodium loses an electron, it becomes a positive charge. And when chlorine gains that electron, it becomes negatively charged. And these two then are attracted because of that positive negative attraction. And now chlorine has 8 valence electrons, and so does sodium. Because when sodium loses this 1 valence electron, it drops down to the next energy level. So when we gain that positive or negative charge, okay, we get what we call an ion. And an ion is an atom or group of atoms that has an electric charge because it has gained or lost an electron. So again, I'm going to go back to the point or the example of sodium and chlorine. So when sodium has that 1 valence electron that's going to hop over to chlorine, it's losing a negative. So when something becomes less negative by 1, it's going to become 1 positive. And one way to think about it is, let's say I have 4 positive charges and I have 4 negative charges, because this is what a neutral atom would look like. Okay, now sodium actually has 11, but I'm just going to draw this up with 4 right now. So if we come in and we take one of these electrons away, I now have a positive 4 plus a negative 3. And when you add those together, that's going to give you a positive 1. So that's how sodium ends up with a positive 1 charge. Okay, chlorine, on the other hand, if chlorine has 7 valence electrons, okay, and now all of a sudden it's gaining this 1 electron from sodium, now it was neutral, okay, so when it had 7 negatives, it also had 7 positives. And we'll make this a little bit more dark. So now what happens is sodium is then going to go in and it's going to gain another negative. So now all these neutral, or kind of like where they're kind of canceling each other out, okay, now I have this extra negative charge on it, so the overall charge then is going to be negative. Okay, and when you have that positive negative occurrence going on, this is what we call an ion. So the attractive force between the oppositely charged ions is what we call an ionic bond. And we will watch the video tomorrow about an ion. Okay, and I apologize, this animation's not working right now. Now, when we're talking about covalent bonds, remember covalent bonds are the type of bonds that share those valence electrons. Sometimes we get covalent bonds that have regions that are attracted more strongly to one atom than another. When that occurs, one end of the molecule has what we call like a partial negative. Okay, so it's a little bit more negative because it's kind of like the electrons are being more attracted to that direction. Therefore, it's going to have a little more negative, which then means that there's going to be another area that has a little more positive because the electrons have kind of left that region. Okay, so we'll have a partially positive and a partially negative region in that molecule. So molecules that have partial charges on opposite ends are said to be polar. And water is a molecule that is a polar molecule. Now, with polar molecules, because you have these partially charged ends, these partially charged ends are actually going to attract opposite charges. So if you have a partial positive, that partially positive region is going to be attracted to negatives because your opposites still attract. Okay, so this creates the instances or the cases of, we say likes dissolve likes, okay? So because of these partially positive, partially negatives, okay, and their attractions, polar molecules can dissolve other polar molecules and ionic compounds. So for example, we said water is a polar molecule, okay, and we said that salt is an ionic compound. So when you put salt in water, it will dissolve, kind of like sugar will dissolve, okay? So this is what we call solubility, Okay, and the saying that is kind of used out there is that likes will dissolve likes. So polar molecules will dissolve other polar molecules, okay, because they're both like molecules. Okay, and this also explains why nonpolar substances, okay, kind of like oil, will not dissolve well in water, okay, because oil being nonpolar and water being polar, they are not like substances, therefore they will not dissolve, okay? And that's why you get that saying where people say oil and water don't mix, okay? And that's because you're dealing with a polar and a nonpolar substance. Okay, so if we look at this picture here, you can see that we have these green spheres, which are chlorine ions. We have the little purple spheres, which are the sodium ions. So the sodium and the chlorine together make sodium chloride or salt. Then you have all these like little red and blue molecules. These are the water molecules, and water is going to dissolve ionic compounds because of the partially positive and partially negative charges. And the last thing that we're going to look at today are what we call hydrogen bonds. Okay, so when bonded to an oxygen, nitrogen, or fluorine atom, a hydrogen atom has a partial charge that's almost as great as a proton's charge. Okay, and the way you can remember this, okay, so hydrogen bonds truly with what we call FON. Okay, so we have fluorine, oxygen, and nitrogen. So in a hydrogen bond, the negative pole of other molecules is going to be attracted to the hydrogen atom. So this attraction is where the name comes, hydrogen bond. Okay, it's stronger than attractions between other molecules, but it's not as strong as a covalent. And again, hydrogen bonding truly only happens between FON or phone, fluorine, oxygen, and nitrogen. So if hydrogen is bonding with like a carbon, that is not a hydrogen bond. That would be considered a covalent bond. Okay, and it's the hydrogen bonding that plays an important role in many of the molecules that make up living things. So here, if you look at this, you can see we have a hydrogen bond going on because I have a hydrogen atom that's being attracted to an oxygen atom. And remember, hydrogen only bonds with fluorine, oxygen, or nitrogen. So this is a true case of a hydrogen bond. And then you can see all these little symbols. These are showing me that we also have partial positive and partial negative charges going on. Okay, so to kind of recap everything from the two parts of Chapter 3, Section 1, it says all matter is made up of atoms. An atom has a positively charged nucleus that's surrounded by a negatively charged electron cloud. Chemical bonds form between groups of atoms because most atoms become stable when they have 8 valence electrons. And polar attractions and hydrogen bonds are forces that play an important role in many of the molecules that make up living things. Please let me know if you have any questions. Otherwise, I will talk to you guys in class, and I hope you guys have a great day.